Welcome to NASA Edge.
An inside and outside look at all things NASA.
Hey, we're here at NASA Langer Research Center in Hampton, Virginia, and we're going to be talking about Discover AQ.
And I'm hoping to actually discover what this massive acronym Discover stands for in the process.
Yeah, in a few minutes I'll be talking to Jim Crawford, who's the principal investigator, and I'm going to ask him that very same question.
And I'm going to be flying on the P3, so I'll be able to ask some of the other researchers what it stands for as well.
You're flying on what?
The P3, one of the planes flying as part of Discover AQ.
How'd you get that gig?
Well, it's not who you know, it's what... No, it's not what you know, it's who you know.
Well, I tell you what. Well, see, just right then and there, that kind of scares me because did you let them know about the magnetospherence level that you produce? Because there's a lot of instruments on board that plane, and if you corrupt the data, the whole mission's a wash.
I honestly thought the health form would rule out the entire flight. So I think they were more focused on that. But I'm also stopping at the Beltville, Maryland ground station.
Okay.
So I'll ask them there too. So.
Well, I tell you what, you prepare for that. I'll go talk to Jim. You're watching NASA Edge.
An inside and outside look at all things.
We got a train whistle blowing here.
Wow.
Hey, welcome to NASA Edge.
An inside and outside look
at all things NASA.
Oh, that's gonna even work.
Hey, we're here with Jim Crawford, the principal investigator for Discover AQ. And Jim, what's Discover AQ stand for?
It's a fairly tortured acronym, but Discover AQ stands for Deriving Information on Surface Conditions from Vertically Resolved and Column Observations Relevant to Air Quality.
Sounds like a dissertation.
There'll be enough information out of this project to cover many dissertations. The number of students involved and scientists, we expect a lot of papers and results to come out of this.
Now, kind of give us the big picture. What's Discover AQ all about?
Well, Discover AQ came from a realization at NASA that we have satellites that can see constituents in the atmosphere that have to do with air quality, but can't see them in a way that's good enough to ascertain what's happening at the surface where people are being exposed to poor air quality. From a regulatory standpoint, the EPA and other regulators want to understand what's happening right here where you and I are standing. They're not even interested as high as maybe a few thousand feet above our heads. So trying to protect health is about what you're breathing now, not about what's present higher in the atmosphere.
And satellites have a tough time detecting that here.
Well, pollution aloft versus pollution at the surface is difficult for satellites because they're looking down from space through the entire atmosphere.
Right.
And so they're measuring the total amount of a constituent throughout that column. Within that column, the pollution is distributed, and trying to determine how much of it is at low versus aloft is a particularly vexing problem. The satellite collects that one piece of information, that total amount in the atmosphere. But how do we tease apart the way it's distributed? And you have to put yourself in different vantage points to be able to do that.
To cover those different vantage points, I've put together a few crude models to illustrate the assets that you might find at a particular ground station. The first vantage point we get from the sun photometer, which is run here by Dr. Xavier. The instrument actually looks directly through the column of atmosphere directly at the sun.
Basically, we know the energy at the top of the atmosphere very precisely in discrete wavelengths that are basically windows for aerosols. This little device measures the energy coming in at the bottom of the atmosphere, and the difference is due to either absorption or scattering by particles in the atmosphere, and we come up with a quantity we call aerosol optical depth.
Looking at pollution, what types of pollution are we looking at? Just aerosol gases?
Well, from a regulatory standpoint, there are two things that are regulated very heavily, and that's particulate matter, or we call it aerosols in the atmosphere, and particularly the small aerosols, things that when you breathe can reach deep into your lungs. Think of it as a natural secondhand smoke.
Right.
And then ozone. Ozone is not emitted in pollution, but it results from the chemical outplay of the degradation of emissions. And so ozone is a highly reactive gas. We tend to think of it as the thing in the stratosphere that protects us from ultraviolet light, but down low near the surface, it's a reactive gas that when you ingest it into your lungs, it reacts with tissues and causes damage.
Right.
Not just to people, but to ecosystems. Agricultural productivity is also degraded by the presence of ozones.
Another asset is the untethered ozone sonde, sonde being the French word for science. We release this ozone sonde into the same column of atmosphere. Ooh. I guess I should have thought about how to recover that.
So what happens with the ozone sondes is that there's a pump on the ozone sonde and it draws in air as the balloon is rising. And then that air will react with a chemical solution that's inside the sonde. And so that chemical reaction creates a current, which we then measure. So we're basically getting real-time measurements of, at this point in the atmosphere, this is the concentration of ozone. We actually put contact information in there. So, comes down somebody's backyard, they can give us a phone call. Hopefully we can make arrangements to pick it up. At the very least, we can be like, it's not going to hurt you. You can stop panicking now.
The tethered ozone sonde actually covers the area of the column from the ground up to 500 feet. And oh look, we have a special guest. Researcher Jim Crawford's here to run camera during a tethered ozone sonde ascent. Release the sondes! Data's looking good.
The other thing we're measuring right now is aerosol spectrum. What that tells us is, for a given size, how many aerosols are present. Aerosols, of course, mean just a little particle of dust.
Okay.
So this instrument measures aerosols from about 200 nanometers up to 20 micrometers. So what we're able to do is provide a profile very low down to compare with what the airplane measures between 1,000 and 5,000 feet.
After taking off from NASA Wallops, the P-3 follows a specific predetermined flight plan covering each of the Discover AQ ground stations. And then, obeying all laws of science and physics, the P-3 flies in over the tethered sonde at 5,000 feet, begins a corkscrew motion safely all the way down to 1,000 feet gathering data, and then heads off to the next ground station.
A satellite looks at particles due to their scattering. So light comes in the atmosphere, and just like in haze, you can see the light being scattered.
Right.
And so they have to ascertain how much particulate matter is there based on a scattering signal. But that scattering signal is a wet signal, and the wetter the particle, the bigger it is, the more it scatters.
Right.
So we have to understand not only the amount of particles in the atmosphere, but what their affinity for water is. Are they ones that like to be wet or ones that tend to shun water? We also have to worry about what they're made of. Sulfate aerosols from burning coal and things like that will tend to reflect light. Black carbon particles from a diesel engine, for instance, will absorb light. And so the difference between the way a particle interacts with light is important, as well as whether it grows in a humidified environment.
And that's why you have so many instruments to actually measure that.
And if you saw the aerosol rack on the plane, 17 instruments, all looking at something different.
Discover AQ also uses automobiles to collect data on Interstate I-95. No, Mr. Scientist, that's not a time machine. That's a regular car fitted with LIDAR to collect data for Discover AQ. Be careful merging onto 95. So the LIDAR mobile, or the Discover AQ mobile, what kind of equipment is this here?
Well, this kind of embodies in a mobile form what we have spread throughout the network. This is a sun photometer.
Okay.
That's a LIDAR, and there's about 10 LIDARs in the network that are basically sending a green pulse of light vertically, measuring how long it takes to be returned. And that timing gives us the position of where the aerosols are suspended in the atmosphere. So these two, with a fixed ground state, are working together mobily. So we're driving the length of I-95 up to the Delaware line, turning around, coming back, and doing these profiles and getting extinction where basically the I-95 corridor.
The cool part about Discover AQ is that all these assets operate at the same time, gathering lots of data in the column. And how do we make all these assets available on the ground? With help from our partners like Howard University and other participating institutions.
The first stop is the Baltimore, Washington, D.C. area, and you're going to be sort of traveling west across the country. Where are some of the sites you're going to be looking at?
Well, first of all, I would say that question comes to us, which is, why do you need to go to other locations in the first place? So think of Baltimore, Washington as that area on the East Coast that represents the endemic problem of the East Coast generates its own pollution, but it also receives everyone else's pollution as it makes its way across the continent, because weather patterns and the general flow of the atmosphere is from west to east. So Maryland represents an opportunity to look at local emissions in the context of also what's coming from upstream. Houston represents a very different condition, and we want to see the variety of factors that drive air quality. So in Houston, you're looking at a place where the petrochemical industry is highly concentrated, and the emissions that come from that lead to a chemical mixture that's actually quite different than you would find, say, in Maryland.
Okay.
And then finally, we find places like the Central Valley of California, where the wintertime is actually when air quality has a big problem. Particulate matter can come from the direct burning of substances, you know, anything from wood burning to crop burning, to actually the crops in the Central Valley and dust being blown up by wind. So all of that particulate matter in the wintertime is squeezed into a very thin atmospheric layer. Without the heating of the sun as much as you get in the summer, things mix into a much smaller volume, and that ends up concentrating it to much higher concentrations. So it's a difficult problem.
Well, Jim, I want to thank you so much. Good luck on your mission. Next
Thanks.
4 or 5 years is going to be wonderful to see. I can't wait to read all the papers down the road. So.
That's right. We're looking forward to it.
You've heard it from Jim. You're watching NASA Edge, an inside and outside look at all things NASA.
I thought these were data gathering instruments, but it was pointed out to me that these are the international colors of safety, not science. So they won't be gathering any data. Oh, it's hot up here. Haven't been this hot since I was roofing back at Shawshank. And for the record, nothing about this air quality needs to be discovered. Lawn maintenance shed. Now here's some equipment I can relate to. Not exactly.